Chapter 1 examples 1.4 and 1.5 are in this video. The problem is let A is a set contains the elements 3, 4, 7, 8. B is a set having 1, 7, 10. Which of the following sets are relations from A to B? Subdivision 1. R1 is a set of all ordered pairs. The elements are 3, 7, 4, 7, 7, 10, and 8, 1. Subdivision 2. R2 is a set of ordered pairs. The elements are 3, 1 and 4, 12. Third subdivision is R3 equal to a set of ordered pairs which are 3, 7, 4, 10, 7, 7, 7, 8, 8, 11, 8, 7, and 8, 10. Solution uh, A cross B. First we write A cross B. A cross B means set of all ordered pairs whose first element is from A and second element is from B. So we're listing first the elements of A cross B. Because the question actually has three subdivisions, three parts, and the three relations are given. We have to check whether these three relations are from A to B or not. That means we should know the meaning of relation and Cartesian product. Relation means just a subset of Cartesian product. So we have to first check whether these three relations are subset or not. If they are subset, we can conclude that the respective relation is a relation from A to B. Otherwise, they are not relations from A to B. These are the conclusion. To prove it's a subset, this R1, R2, R3 as a subset of A cross B, we have to check each of the element from that R1, R2, R3 is an element of A cross B. To prove it's not a subset, it's enough to show only one element from the respective R from only one element from R is not an element of A cross B. It's the conclusion for R being not a relation from A to B. So let us check the first subdivision. Here R1's element 3, 7, 4, 7, 7, 10, 8, 1 all are in A cross B. 3, 1 is first element of A cross B, but we are taking R1. So 3, 7 it is the second element of A cross B. 4, 7 is also there. 7, 10 in R1 is in the set A cross B. Next, last element of R1 8, 1, which is also exists in A cross B. So every element of R1 is an element of A cross B. Hence, we can give the conclusion that R1 is a relation from A to B. Second subdivision is to check R2 is a relation or not from A to B. R2, if you consider first element 3, 1, it's an element of A cross B. And second element 4, 12, it's not belonging to A cross B. Therefore, we can conclude that R2 is not a relation from A to B. Now, third subdivision R3, if we consider 3, 7, 4, 10, 7, 7, they are all elements of A cross B, but 7, 8 is an element of R3, but it is not an element of A cross B. Therefore, R3 is not a relation from A to B. Uh, by usual checking procedure, we check each element is either in A cross B or not. But indirectly, we can say whether the first element of the ordered pairs are belonging to A. Just a glance, we can obtain any odd man, that is any element which is not belonging to A, then pick that ordered pair and give the conclusion. Similarly, for second element of the ordered pair, and looking at if any element which is not in B, we can pick that ordered pair and give the conclusion that they are not relations because of the ordered pair not belonging to A cross B. In either way, to conclude given one is relation, we have to prove that each of the element, we have to check, of course, each of the element is an element of A cross B. But to prove it's not a subset, it's sufficient to prove one ordered pair is not an element of A cross B, and we can give the conclusion. Hence, 1.4 is example completed. Next problem, example 1.5. The arrow diagram shows figure 1.10, a relationship between P and Q. Write the relation in subdivision 1, set builder form, subdivision 2, roster form, and third subdivision is what is the domain and range of R. So actual question contains P and Q two sets, and the relationship between these two sets are given in this figure. This arrow diagram represents. Now we have to first write this relationship as a set builder format. So first R equal to open bracket, set bracket, then set of all ordered pairs uh, in the generalized form is x comma y, such that we have to represent y as well as x. So y here is x minus 2 because the element 5 is related to 3, and 6 to 4, and 7 is mapped to 5. Each of the element in P is related to an element in Q which is just less than 2. So we are writing y equal to x minus 2, where x belongs to P and y belongs to Q. Hence, the set builder form is completed. Second subdivision roster form, directly write the ordered pairs. So 5 comma 3, 6 comma 4, and 7 comma 5. Here we don't bother about the element which is not having an image. So just write the ordered pairs which are related. Third subdivision is domain. Domain of R means first we write all the elements in first set which are having related element in Q. Last element is not connected, so we just omit that element. And range of R is the codomain element which is having pre-image is range here 3, 4, 5. So we are completing the third subdivision now.